We're talking about projectile problems today. So we want to look at what is the motion for a projectile. What happens to it? So we're going to look at a formula. If you'll remember back that this is h is the height is equal to negative 16 times t squared, where t is the time, plus v naught, our velocity, times time, plus s naught, which is the initial height. So we're looking at this formula and we're going to try and determine some of the different parts of it. Tia stands on the top of the Bank of America building. She is in Dallas and she is at the top of the tallest building, 921 feet above the sidewalk below. She, oh my goodness, drops a water bottle. And oh, she's got to find out how much, oh my goodness, how much time is it going to take before she can tell someone below that it's going to hit them in the head? So we need to find out this. So we're looking at, what is the height? Well, when it hits the ground below, the height is 0. That is that is the height at the ground. So now then we're going to look at negative 16 t squared. Initial velocity, well, if she just dropped it, the velocity is 0. It's just using the gravitational pull. Now, what is our initial height? Well, that's that tallest building, 921 feet. So we've got our problem here. We have one variable. We want to isolate that variable and we want to solve to see what would t be. So I'm going to get, if I add the negative 16 to both sides, I'm going to get 16t squared is equal to 921. Don't forget the squared. That could cause problems. So if I isolate the variable, I'm going to divide by 16 on both sides, and t squared is equal to 921 over 16.
Now hold on a minute. I like the quadratic formula.
Oh, but sometimes the quadratic formula is not the most efficient. If you look here, all I have to do is take the square root of both sides. That will give me t is equal to positive or negative square root of 921 over 16.
But if I really wanted to use the quadratic formula?
Well, you could use it, but you have to remember that that would mean that 0, our initial velocity, was your b when you put it in the quadratic formula. It'll work the same way. You'll get the same numbers, but it's a little more efficient to do this. So t is equal to plus or minus 7 and 59/100 seconds. This is time, so we're talking in seconds here. Now, positive or negative? Somehow I'm thinking we're not going back in time. So when it hits the ground, that's going to be 7 and 59 seconds, 7 and 59/100 of a second after she drops it. So our answer here is going to be a positive answer. We can't use negative. We're not going backwards in time. We are looking at what happens in the future. So approximately 7, she's got 7.5 seconds to reach down below and warn someone. All right? So now then we've looked at this. What happens if she threw it? Someone's down there and she really wants to throw it. How long is it going to take her then? Oh my goodness. Oh! And it hits the ground below. Is it going to take less time or more time? What's going to happen? Well, let's look at Tia's problem again. We're going to use the same formula. This is going to be B part. Our same formula, h, is the height. Well, again, we're going to hit the ground below, so that's 0. We're going to say negative 16t squared, plus this time our initial velocity, well, that is, in our problem, 20 feet per second. So we're going to look at 20 times t, plus, again, she's at the top of the building, so that's 921 feet. Now, in this case, I can't isolate a variable because I have a squared term and I have a t term, just the t term. So I can't isolate that variable as I did over here. So I must use the quadratic formula. So when I look at this, now the quadratic formula has an x with it, but since our variable is t, we can say the same thing. T is equal to, well, do we remember it? That is the negative of b, our term, plus or minus the square root of b squared minus 4 times a. Now remember that a is a negative 16 times c all over 2 times, again, a negative 16a. So we've got our quadratic formula here. Now, I did this a little bit ahead of time, and so you're going to put this in your calculator. Be very careful when you put this in your calculator because you've got to make sure that you're using the order of operations correctly. Your calculator knows them. If you haven't put it in correctly, it will have problems. So make sure you're very careful about this. When we do this, we get t is equal to either a -6 and 99 seconds, or we get 8 and 2400 seconds. Now again, we're not going in the past, we're looking in the future. So this is our reasonable answer. This is not reasonable because that's past. We're looking in the future. And so our time would be 8 and 2400 seconds. Now, it took a little bit longer because we threw it, okay? So now then, let's see what happens. What if our question's a little different? We've looked at how long does it take to go to the ground. Now our next question says, after how many seconds will the dropped bottle be 500 feet from the ground? So now we're not looking at going to 0 feet, we're looking at 500 feet. So our height here is 500 feet, so we're looking at 500. That's our height that we want it to be, is equal to -16t squared plus, now we have to determine here, our initial velocity. Have we thrown it or are we dropping it? Remember, the initial velocity, if we drop it, is going to be 0. If we throw it, we have a number in there. So when we do 0 in our formula, 0 times t, we don't. We've just dropped it, so we do not have a velocity other than 0. Now our height, again, is 921 feet. We could use the quadratic formula, but our problem here is we have to be equal to 0.
Oh boy, I used the quadratic formula with A, B, and C.
But our problem is our quadratic formula is A, B, and C if we have AT squared plus BT plus C. This is not a t term, so we can't do that. So we've got to solve, and also it's based on that being equal to 0. Remember that equation has to be equal to 0. So we can subtract from both sides and ultimately get 16t squared is equal to 421. Now when we solve for t squared, we get t squared is equal to 421 over 16. Take the square root of both sides. Again, if you wanted to use the quadratic formula, but that b has to be 0, then t is equal to, and we're going to go with the positive value, 5 and 1300 seconds. We've looked at several different projectile problems today. Make sure that you read carefully. One is that we have dropped it. One is that we have thrown it. That changes our velocity. We are also looking at initial height, how high off the ground. And then our 0 here is if it hits the ground or how far down it's gone.